Okay, so what I want to show is a method of generating targets, crossover targets. You can use it in pretty much any program. REW is what I'll be showing right now. I've tried to make this video a bunch of times, and I always get too complicated with it, and so I think what I'm going to do is just show just basic how to do it and use your imagination. You can it's pretty much unlimited. Anything you can, you're only limited by your imagination basically, but that's life anyway. So okay, first of all, there's a program called EKIO you're going to want to download. You're also, of course, REW, right? And then there's another one called Voicemeeter. They're all free. So you download and open up Voicemeeter, download and open up EKIO, and download and open up REW, which I'm sure everybody has already done that. So EKIO functions as a software-based DSP. So it's just a digital signal processor that is entirely in software. It can communicate with ASIO devices. So we're going to go File, New. We're going to add a couple input channels. We're going to add a couple output channels. We're going to come over here to Settings. We're going to select Voicemeeter as our audio interface. So the reason I had you download Voicemeeter is because it is a virtual audio interface. So there's no external audio interface required. This is done completely inside the computer. So I set my sample rate to 48K because my Voicemeeter is set to 48K. Okay. Anyway, inputs, outputs, we're going to select 1 and 2 for our ins, and we're going to just select 3 and 4 for our outs, just because it's easy like that. So 3 and 4. Okay, great. Now we can go ahead and hit play. We're going to come over here to Preferences, and we're going to select 1 and 2 for our outs to feed 1 and 2 of EKIO. And then our input for REW is going to be 3 and 4 because our output from EKIO is 3 and 4. Okay, very simple. All right, now we're just going to click Measure, and we're just going to do this as a sanity check to make sure that we get a straight line, which we do not. Okay, we don't get anything. The reason we don't get anything is because I forgot to route my signals in EKIO, input to output. So let's go into routing. We're going to route input 1 to output 1, input 2 to output 2. Now, let's do that one more time. Okay, so now we're going to get basically a what's called a DRAC pulse, which is just, oh look, that's not perfect though. Look at there. Look at there. That's not perfect. Anyway, it should be just a perfect impulse. Yeah, good enough. Okay, so I don't know why it's dropping off down here on the extreme low end, but it's really nothing to worry about. That's like 2-3 hertz. Anyway, so yeah, so basically you get just a flat line all the way across the spectrum, magnitude and phase, which tells us that all of our signals are coming into and out of the analyzer correctly and the DSP correctly. So now if we just come to our output number 1 and add a filter, let's turn this into a low pass filter at 1000 hertz, Butterworth 12 dB. Let's see what happens. Let's measure that guy. See what we get. Perfect. We get exactly what we would expect to get. Let's turn this to a Linkwitz-Riley 24 dB. Let's see what we get. So anyway, you can use this to generate targets that you can then use as guidelines, acoustic targets, guides for system tuning. And you can add a whole bunch of filters to each one of these. You see, you can pretty much do whatever you want. It's pretty unlimited, pretty awesome. You can also set it up to view the sum of a crossover filter. Like, how would a crossover filter sum if I were to use, some arbitrary, like a low pass Butterworth summed with a high pass Bessel or something like that. You can see what that would be. In order to look at the sum of filters, you have to change your routing. You have to route both inputs to a single output. Now what we're going to do is we're going to be doing our filters on the input side of things, not on the output side. So for example, we can put a low pass filter on channel 1 and a high pass filter on channel 2. And since both of those input 1 and input 2 are feeding output number 1, which is connected to software channel 3, what software channel 3 is going to represent is the sum of these two channels. So we need to change our reference, since number 4 right here is over here on EKIO is no longer serving as our timing reference. We need to select our timing reference as either 1 or 2, as one of these two guys. What that's going to do now is the latency of the DSP is going to be included in the phase data. So we're going to have to offset our IR if we want accurate phase data, which I'll show you how to do that in just a second. For now, let's do this. Let's bypass our inputs and let's look at just one. Okay. Okay, so we get our flat line in the magnitude, but our phase shows a lot of broadband delay. So we can go estimate IR delay, 10.67 milliseconds. So if we hit Shift IR, there you go. Now you got flat phase, and now you know it's 10.67 milliseconds that you need to compensate for. So we can turn this back on. So now we have both of our inputs feeding a single output again in our DSP. And then let's go over here and let's take a look again at our filters that we were interested in. So now we're going to look at the sum of a Butterworth filter, neither channel inverted. Okay, and remember it was 10.67 milliseconds. So let's measure that. We should get a big null. We do. We get a big null just like we would expect because one of our channels is not inverted. So let's go to impulse, and then right here we're going to put in negative 10.67. If you forgot that number, you can always come over here and look, and it says right here 10.67. So right here we're going to go 10.67, apply. Now we should have accurate phase data, and we do. Okay, so now let's come back over here to EKIO and invert one of those channels. Now that null should be gone, and it should be a little 3 dB hump, and it is. And again, if we come over to impulse and input 10.67, hit apply, look at our phase. We have accurate phase data. There you go. So that's how you would look at the sum of two filters. You could also go like this. You could also go, you could bypass one, hit measure.
Yeah. And I brought that router.
Oh, right on. Okay, and we'll go impulse controls again. I wish there was a faster way to do this in REW. There might be, I don't know. I don't really use REW that often, or actually I never use it for this kind of thing. So anyway, so there's that. Now this is odd. We got a little hump right here. I'm not sure what's going on with that, but you know, that's the beauty of this stuff. You can low pass is not bypassed, high pass is bypassed. What in the world did I do? Huh, that is indeed strange. Okay, so it looks like what we just measured was a high pass filter, but I bypassed my high pass filter. That is so odd. Okay, let's see. Let's see what's going on here. Okay, so let's bypass our low pass filter. See what we get. See, I would think this is our high pass measurement. It's not, it's our low pass measurement. So that's really weird. So that's some weird stuff. I don't know what the hell's going on there. Oh, yes, I do. This is what I did. Okay, look. you got to come in here to the routing and you got to turn off one of those two channels, because it's showing the sum of the two channels. So if you want to look at just the individual, like if you want to take a trace of the low pass, then the high pass, then the sum, so that you have a target of all of those things, you would want to go, like for example, input 1 to output 1. So we're going to look at our input 1. This is going to be the filter we're going to look at. We just turn off channel 2, the routing. We just turn it off completely, so it's not routed to our summed output anymore. And so now we should see a low pass filter, a textbook low pass filter. There you go. Perfect. So yeah, so that's that. Then you would go like this. You would go, since your phase is going to be all wacky, too much broadband delay, you're going to come over here and do your 10.67 again. Apply and SPL phase. So there's your SPL phase for that one. And then you can come over to EKIO and instead route this guy through. Whoops, make sure that your filter isn't bypassed. I think yeah, no, we're good. Okay. Okay, and let's remove that broadband delay from that guy as well. Okay, and now we can come over to EKIO and just simply turn them both on. Now we're going to measure the sum. You know, it's a good learning tool as well. And let's take our broadband delay out of there as well. 10.67. Apply. There you go. So now if we come to overlays and we look at just the, let's minus that down a little bit. Let's look at just the last three. So that will be 11, 10, and 9. There you go. So see, you can, you know, you can really learn a lot about how filters behave, and same with phase. 11, 10, and 9. And 9, 10, and 11. Okay. Man, I hate those little pop-up things. And 11. 10. There's 9. 10. 11. So that's that. What else is there? I don't know. Use your imagination from here.